Hello Math Analysis students. In this video we are going to go over the solutions for the calculator part of the review where we work on inverse trig. This one is shorter than the front side, and for this one you do need a calculator. I will be using the Desmos graphing calculator. For these first 6 problems, all we're going to do is punch this into Desmos just as it appears. The thing we need to pay attention to up here is that it asks us to round all trig values to 4 decimal places and to give all angles in degrees. So we want to make sure that we are rounding these to 4 decimal places. Okay, so the first one we're going to do is sine 24. We want to come over here to Desmos. Now, we do need to make sure for this that we are in degree mode, not radian. For Desmos, the default mode is radians. So you want to come up here to the little wrench, and then at the bottom you'll see that radians is highlighted because that is its default. You want to switch it over to degrees. After that, we are just typing in exactly what the problem was. This first one was sine of 24, so we can either type in the word sine, or as I prefer to do, to go to the keyboard and type in the functions, the sine of 24, and it will give us this number right here, and we need to round this to 4 decimal places. Now that means we want to write 4 places after the decimal, but we have to look at the 5th value to see if that makes the 4th one stay or if it makes it go up. So this we need to see, is it 0.4067 or would it round up to 0.4068? This 3 says stay where it is, so that first one is 0.4067. And so 0.4067. You can write the 0 out front. You don't have to write the 0 out front. That's up to you. For the cotangent of negative 48 degrees, again, you can either type or use the function button. Cotangent negative 48, and we get negative 0.9004. We do the same for the other values. I'm not going to actually show doing all of those, but for tangent of 322, we get negative 0.7813. The cosecant of 82 is 1.0098. The cosine of 40 is 0.7660. And the secant of negative 109 is negative 3.0716. Okay, for the next part, we're asked about 2 problems. We're given this cosine of theta is this. What is the reference angle? So for this, we still want to use Desmos, but we want to use it in the reverse order. So if we're finding theta, we're finding the angle, then what we're going to put into Desmos will be the inverse cosine of 0.2486. And the same thing with this one right here, we would put in the inverse secant of 2.8344. So for the inverse cosine of 0.2486, we'll go over there. I will go under the functions, and you'll see that up here you have your 6, and then you have your inverse trig functions. So if we're doing inverse cosine, we'll just click on inverse cosine and put in our numbers of 0.2486. And this gives us 75.6. We're going to round these to tenths places. I think the directions said degrees, but on the test it's actually going to say tenths place. So we're going to go with 75.6 degrees. And it actually asked us, what is the reference angle? Remember that reference angle has to be a positive acute value. And we have that here. 75.6 is positive, and it is acute because it is between 0 and 90. For our next one, we're going to do the inverse secant. So we'll find inverse secant of 2.8344, and we get 69.3. Okay, and so that's our answer. That is a positive acute angle. And so it is 69.3. If we had gotten something that was not a positive acute angle, then we would need to find the reference angle, which is how far is it from the nearest x-axis. Our next 3 problems, these are the ones that are the trickiest. So we are going to just work through them step by step. We have a couple of parts. For the first part, we're asked to find a reference angle and then talk about which quadrants we should be looking at and then what the angles are. So for this first one, cosine theta equals negative 0.1635. So we're going to go to Desmos. We're going to put in the inverse cosine. So we're going to do inverse cosine of negative 0.1635. And we get 99.4. Okay, 99.4. Now I'm going to write that over here, but that is actually not a reference angle, okay? Because a reference angle, remember we just said, has to be positive and acute. 99.4 is not an acute angle. But how far is this angle from the nearest x-axis? Well, remember 99.4 would be somewhere over here in the second quadrant. How far is it from the x-axis, which is 180 degrees? We subtract 180 minus 99.4, and we get that our reference angle is 80.6. Now, cosine is negative in which quadrants? So cosine is their x value, so that is negative in quadrants 2 and 3. So we need to find the angles in those quadrants that are this far away from the x-axis. In quadrant 2, well, that 99.4, that is a second quadrant angle. So our second quadrant angle is 99.4. And our third quadrant angle, we're looking for what angle is down here in the third quadrant. That's 80.6 degrees past 180. So we do 180 plus that 80.6, and we get 260.6 degrees. Now we'll do the same process with our other angles. For this next one, the sine of theta is negative 0.7294. So let's find the reference angle. We're going to go to Desmos, and we're going to do the inverse sine of, I lost my value here, negative 0.7294. It's rounded to the nearest tenth. It's negative 46.8. Okay, so we got a negative 46.8, but a reference angle has to be a positive acute value. This is still acute, you know. If we just take the absolute value of this, then their reference angle would be 46.8. Sine is negative in which quadrants? Well, sine is their y coordinate, so that is down here in quadrants 3 and 4. So we're looking for which angles in quadrants 3 and 4 are 46.8 degrees away from our x-axis. So in the third quadrant, it's 180 is our nearest x-axis. So we'll do 180 plus that 46.8. And that gives us our value of 226.8. And for the fourth quadrant, we're looking for our closest x-axis is 360. So what angle is 46.8 degrees away from 360? So we do 360 minus 46.8, and we get our value of 313.2. Make sure that your angles are actually in the quadrants you specified. Like 226.8 is actually in the third quadrant, yes, between 180 and 270. And this is actually a fourth quadrant angle, yes, between 270 and 360. And we do the same for our last one. The cotangent of theta equals 0.1895. So we'll go to Desmos and we'll do the inverse cotangent. Inverse cotangent of 0.1895. We get 79.3 degrees because of rounding. And that is itself a positive acute angle. So 79.3 is our reference angle. Now, where is cotangent positive? Since tangent and cotangent are reciprocal functions, they are both positive where the x and the y values have the same sign, positive or negative, which is going to be quadrant 1 and quadrant 3. Because in quadrant 1, x and y are both positive, so when we do x divided by y, it will be positive. And in quadrant 3, x and y are both negative, so when we do cotangent x divided by y, then we would get positive. So this is quadrants 1 and 3. All right, in the first quadrant, that angle is just 79.3. And in the third quadrant, we're looking for, past 180. What is going to be 79.3 degrees past 180? So we'll take 180 and add 79.3, and we get 259.3 degrees. And there you have it.